Hey everybody, this is Mr. Bortnick for AP Calculus AB. We are in Unit 2, Differentiation, the definition, and basic derivative rules. Today's focus is topic 2.9, which is the quotient rule. Enjoy. All right, for 2.9 on the quotient rule, I just want to quickly remind us of our last section. In 2.8, we learned about this thing that was called the product rule. And we remember that the product rule helps us find the derivative of two functions being multiplied together. And the rule that we had said was if our original function was f of x times g of x, so we'll say the main function is h of x. So if h of x is equal to f of x times g of x, the product rule says that the derivative here is going to be that h prime is equal to the derivative of the first function, f prime of x, times the second function, plus the original first function times the derivative of the second function. Again, this is our product rule. And this is how we find the derivative of functions that are being multiplied together. Now, today we're moving on to 2.9, which is what's called the quotient rule, which, similar to in name, it is very aptly named, right? Product, the word product is a multiplication, or the result of multiplication, and a quotient is the result of division. So we can see here that if we call h of x equal to f of x divided by g of x, so I'm going to say that we have two functions that are being divided here for our quotient rule. If we're dividing those two functions and we want to find the derivative, we use this thing called the quotient rule. So again, the quotient rule is a rule used to find the derivative of two functions being divided. Now, back up here when we did the product rule, the order that we had these two terms here didn't really matter much because we were adding. And for example, like if you are adding two numbers, just as a straight example, if I said 5 plus 3, we know that that's 8. We also know that that's the same thing as 3 plus 5. When you are adding two things, the order does not matter. In this case, the quotient rule is very specific in its order. You have to make sure that you do this quotient rule a specific way because it has some subtraction involved. So what is that quotient rule? Well, the quotient rule is we're going to take the denominator, that's our g of x, we're going to multiply it by the derivative of the numerator. We're going to then subtract, and then it's going to be our numerator times the derivative of the denominator, and this is going to be all divided by the denominator squared. It is it's a pretty useful rule for us to be able to take derivatives of two things that are being divided, but in this case, it's a little bit of a longer rule compared to other ones. Notice that, I'm not just taking the derivative of the numerator and denominator and leaving it like that. A very common misconception with the quotient rule is I could just take the derivative of f of x and divide that by the derivative of g of x. Notice that this is not what's going on here. There's some multiplication, some subtraction, and some squaring that needs to be going on in order to find that. And again, we know that the AP exam is half no calculator. And so we know that some rules, like these derivative rules, we're going to have memorized. And one way that that some of my students in the past have memorized this before is we refer to this top function as the high function, and we refer to this bottom function as the low function. And the way that I remember it, and this is actually the way that I remember it, is I remember it by saying the phrase low d high minus high d low all over low squared. So low d high minus high d low all over low squared. And when we're talking about like d low, we're talking about the derivative, or d high, it's the derivative of the top part, the high part. The d low is the derivative of the lower part, which would be this g of x. And so we can see this matches up. G of x is our low, that's g of x. The derivative of the high, that's the derivative of f prime of x, minus our high, which is f of x, times the derivative of our low, which is g prime of x. And that's being divided by the denominator, or low squared, so g of x quantity squared. Let's see this in some problems. So for problem number 1, we've got y is equal to 2x squared divided by 3x plus 1. What I would do first, especially if I'm using this, and certainly as you're doing this for the first couple times, I think it's going to be useful for you to identify what your f of x and your g of x are. So in this case, we notice that our f of x is our top function in this rule, and our g of x is our bottom function in this rule. So I'm going to just very quickly label these, that f of x is going to be equal to the 2x squared. G of x, in this case, is going to equal 3x plus 1. So we have both of those things here on the side. And we want to also use their derivatives because we see that we're going to need those derivatives in those rules. So if we take the derivative of 2x squared using our power rule, we know that f prime of x would be 4x. And if we took the derivative of g of x, we would get g prime of x, and the derivative of 3x plus 1 would just be 3. So we have this over here sort of as our side work that we've got. And so let's get into our actual derivative here using our quotient rule. So y prime, the derivative of y, is going to be equal to low d high. So g of x is 3x plus 1 times the derivative of f prime of x. Derivative of f prime of x we said was 4x minus high, so that's our 2x squared. 2x squared, whoops, back that up, don't forget that squared, times d low, which was 3. And that's all being divided by low squared, that original denominator squared, so 3x plus 1 quantity squared. Now, if this were the AP exam and you were in the free response section and they asked you to take a derivative on one of those parts, this would be it. You'd be done. You don't need to simplify it all. But we also know that sometimes, we might be on like the multiple choice section or something like that where they have specific answers. And very frequently those specific answers are going to require you to, maybe simplify this numerator or factor some things out. So let's think about how we might do that here. So in this case, we notice that this 4x can distribute to both of these terms here. And so if we do that, we get that y prime is equal to, 12x squared plus 4x minus 2x squared times 3, which is 6x squared. That denominator I'm going to leave alone. I'm going to leave that as 3x plus 1 quantity squared. And then we're going to combine our like terms. We see here that the 12x squared and the minus 6x squared can simplify. So that's going to be 6x squared plus 4x, all divided by 3x plus 1 quantity squared. And that's going to be it. That's our derivative function for our original y. Again, what does a derivative find? We know that that this expression for y prime would tell us the slope of the tangent line at any given x value on this original y equation. Nice. All right, that's number 1. Let's move on to number 2. I'm going to do the same thing here. Again, we're going to remember that our numerator, even though these have e to the x's and they're exponential functions, we're going to still label the numerator as f of x and the denominator as g of x. So in this case, our f of x is 3e to the x. Our g of x is equal to 2x. If we take the derivative of each of those, the derivative of e to the x, we know that e to the x is a special function, exponential function, that is its own derivative. So the derivative of 3e to the x is still going to be 3e to the x. And we know that the derivative of 2x is going to be just 2. So here's our side work. We're going to put that aside and we're going to get now to our derivative. The original function was g of x, so I'm going to call its derivative g prime. And let's do our quotient rule. So again, sort of looking up here as our format for this, we need to put g first times f prime of x minus f of x times g prime of x in that numerator. So our g of x here was 2x. We're multiplying by f prime of x, which was 3e to the x. We're subtracting our f of x, which is 3e to the x, times g prime of x, which is 2. And then we're going to divide by that denominator squared, so that's going to be 2x quantity squared for that. Again, if this were free response, this would be a totally acceptable place to stop. You had done your work. But again, it's useful sometimes to simplify, especially if we're plugging in numbers or if we're trying to deal with a multiple choice problem. So let's do that and try to simplify this. So if we keep going and we keep multiplying, this 2x times this 3e to the x, that's going to give me, 6x e to the x. and then we've got a minus 6e to the x, and then in that denominator I've got a 4x squared if I square both that 2 and that x. What can I do further? You know, this might be an answer on a multiple choice, or we might need to go say a step further. Here I notice that both of these terms have a 6, and both of these terms have an e to the x. So if I needed to, I could factor to try to get in a particular form. That would be like 6e to the x times x minus 1, all divided by that 4x squared. This at this point is probably as simplified as we're going to get it. There's nothing that can cancel out here. We can't really factor anymore. But again, this would be our derivative function for g of x. And so if I want to know the slope of the tangent line, we could plug in our x value at any point to find the slope of that tangent line. Nice. That's number 2. All right, let's try number 3. We've got these ones here where we can have some trig functions. So quickly here, our f of x is equal to sine of x. Our f prime of x is equal, then the derivative of sine of x is cosine of x. Our g of x here is 2x squared minus 5, and the derivative of that, g prime of x, is 4x. We've got that side work, so we're going to now do our derivative. So low is 2x squared minus 5. The derivative of sine is cosine of x minus the original numerator sine of x times the derivative of the denominator, which was that 4x. And that's all being divided by that denominator squared. So 2x squared minus 5 quantity squared. Here in this case, what could we do? Again, we could go further and we could try to simplify this. In this case, we need to distribute that cosine to both of these terms. But I'm going to actually just leave this one here for this particular problem. And we're going to go on to number 4. Number 4, this is simply just a reminder that you want to try to look to see if you can simplify these problems first. This is a great example where simplifying first is useful. So it's helpful. So it is helpful. What does that mean in this case? Well, I do see two functions that are being divided here, right? 3x plus 1 is being divided by that 2x squared. So I could absolutely use the quotient rule on this. But in this case, our quotient rule is actually a little bit of overkill because I can rewrite this in a way that allows us to just use the power rule. How would I do that? Well, I notice that this 3x is being divided by the 2x squared, and I also notice that this 1 is being divided by this 2x squared. So what I could do is I could actually rewrite this function, h of x, the original function, is just 3x divided by 2x squared plus 1 over 2x squared. I just split this fraction up into 2 parts. Why would I do that? Well, notice that I can actually cancel some of these things out and rewrite this, that I can reuse then the power rule in order to do it. What does that look like? Well, h of x is going to be equal to our x divided by our x squared is going to be x to the negative 1. So I have 3 over 2 times x to the negative 1 plus the 1/2 times x to the negative 2 power. Now, these are just regular polynomial functions with some coefficients, and I could just use my power rule from way back when earlier in this chapter. And I don't need to do the quotient rule. So what would that derivative look like using that power rule? We'd have that 3 over 2 times negative 1 times x to the negative 2 plus 1/2 times negative 2 times x to the negative 3. And so that h prime of x here is going to equal negative 3 over 2, and that x squared, because it has a negative exponent, is going to go in the denominator. So negative 3 over 2x squared. And then we've got what looks like a minus, because we've got 1/2 times negative 2, so that's negative 1. So negative 1 over x cubed. And again, that's in the denominator because we've got that negative exponent here. So this would be our derivative function for number 4. Now again, some of these it's sort of identifying, and some of these problems, especially if they don't tell you whether to use the quotient rule or not, if you see division, you're welcome to use the quotient rule. That would have been fine in this problem. You would have gotten something that probably looks a little different from this, but it would be equivalent. It would just be something written in a different form. And that's totally fine. Unless they specify a particular rule, you're welcome to use any one of them that's applicable. All right, we're on to our last 2 problems for this. Let's talk about how we do this with tables. This is a super common way that this is tested on the AP exam, where they don't actually give you functions, right? We don't have f of x and g of x. We don't know what those are, but we do know the values of those functions at a specific x value. So I would say this is an extremely common AP exam free response style question where you are given a table and you're asked to do either the product rule or the quotient rule. So let's do it. If h of x is equal to f of x divided by 3g of x, if we use our quotient rule here, we could say that h prime of x is going to be the denominator, right, 3g of x times the derivative of the numerator, so times f prime of x, minus the original numerator times the derivative of the denominator, so 3g prime of x. And that's all divided by the denominator squared. So this is the setup with our quotient rule. All we would need to do now is notice that they're asking us when x is equal to 2. So we're going to put that in for each of these x's. And then we're going to be able to use our table values to figure out what those are going to be. So h prime of 2 is going to equal 3 times g of 2. So 3 times g of 2. G of 2 from our table is -1. F prime of -2, or f prime of 2 rather, is -2. We've got then minus f of 2. So f of 2 is 4 times 3 times g prime of 2, which is 2. So 3 times 2. And that's being divided by 3 times g of 2, which is 3 times -1 squared. At this point, now that we've looked at the table and we've found those values, all we need to do really here is simplify. So we see that this is, -3 times -6, so that's a +6, minus 4 times 3 times 2, so that's 12 times 2, that's 24. And then that's divided by -3 squared, which is 9. So 6 minus 24 would be -18. That's being divided by 9. Our answer here is -2. Very cool that I could apply this quotient rule even when I don't know what the numerator and denominator are, right? We don't know what f of x and g of x are. They only gave us a handful of values, but we were still able to use those to find the derivative. Very cool. All right, number 6. And this will be our last one for today. First off, this is a big one to notice. Be careful. Hey, there's a little negative sign out here. This negative sign is essentially a coefficient, right? And we know that from earlier in this chapter that when there's a coefficient in our derivative, that we can essentially take the derivative of the rest of it. So what you'll notice is I'm going to take the derivative of this piece and I'm going to leave that negative on the outside. That's going to make our work a little bit easier as we go along. So what is r prime of x? R prime of x is equal to the negative, so we've got a negative out here, and I've got all the rest of the stuff. So from our quotient rule, it's going to be 1 minus f of x times g prime of x minus g of x times the derivative of the denominator, so that would be negative f prime of x. And that's being divided by the denominator squared, so 1 minus f of x quantity squared. I just wanted to point out here, right, this negative f prime of x, right, that's the derivative of 1 minus f prime of x. The derivative of 1 is 0, so that goes away. And so we're left with just negative f of x, and that derivative of f of x would be f prime. Great, let's plug in. So they want to know here at x is equal to 2, which is helpful because that's the only x value we know from this table. So r prime of 2 is going to be equal to, we've got this negative still on the outside, of 1 minus f of 2. f of 2 is 4. And then we've got multiplied by g prime of 2, which is 2. Then we've got minus g of 2, which is -1. Times negative f prime of 2, so that is a -2, and that's being divided by 1 minus f of x, so 1 minus 4 squared. Great. Let's simplify. So this negative is still on the outside. We've got 1 minus 4, so that's -3 times 2 is -6. We then have a -1 times a +2, so that's a -2, but then there's a negative in the front, so I've got a +2 here. And then we're being divided by -3 squared, so that is a 9 down here. And let's simplify here in the parentheses. This looks like we've got -6 plus 2 is -4 over 9. And then we're going to change the sign so these two negatives cancel each other out here in this last step to tell us that the answer is 4 over 9. And that's going to be our derivative of r of x using the quotient rule when x is equal to 2. That's going to be it for today's notes. We've got a bunch of practice after this, so a lot of practice for you to try. The solutions are posted as usual. Please come to class with any questions that you've got. If you want to see some extra examples, let me know. Otherwise, have a great rest of your day. Take care.